So in this video, we're going to draw sketches of polynomial functions. So in order to create an accurate sketch here, we're going to do a couple of things. First, we're going to use our knowledge of end behavior to have an idea of what's going to happen on the endings of our graph. And then we're going to find points on the graph so that we can plot them and get a general idea of where this is going to go. So, to begin, let's look at the fact that this is an odd function because the highest power is 3. And as a result, the ends are going to point in opposite directions. Then from here, because the leading coefficient is a -1, that leading coefficient of -1 tells me that the right side of the graph is going to point downwards. So this graph is going to look something like this. It's not exactly that, but it's going to have one side going downwards, one side going upwards, with the side going downwards being the right side. Now what we're going to do for this is we're just going to create a table of values, and we're just going to substitute values in place of x, and we're just going to evaluate what x would be to find y. So I'm just going to pick values of -2, -1, 0, 1, and 2, and I'm going to plug those values into my function here in order to find corresponding y values so that I can then plot them on the graph. Now, something to keep in mind as you calculate these points, remember that the coefficient of x cubed there is -1, so I have -1 times my x value cubed plus my x value squared plus 3 times my x value minus 3. So you can calculate these by hand or using a calculator, it doesn't matter to me. So using my calculator here, I plugged in -2 in place of x, and I found that y is equal to 3. I then am doing the same thing with -1. And I'm finding that my y value is -4. Then I'm doing the same thing with 0. And I find that I have a y value of -3. Then doing the same thing with 1. I end up with a y value of 0. And then repeating that one more time with 2. I end up with a y value of -1. So now I can just move over to my coordinate plane and plot these. So I have x is -2, y is 3, -1, -4, 0, -3, 1, 0, 2, -1. So if I kind of just play connect the dots here, I can get a general idea of the fact that this graph is doing something like this. And essentially, it's kind of exactly what I expected. It's going up on the left, down on the right, and continues with those end behaviors that I predicted. So we created a little set of points here, plotted them on the graph, and matched it to our end behavior. So let's repeat this one more time with another example. So what I notice here is that this is an even function, and as a result, both ends are going to go the same direction, either both up or both down. And then my leading coefficient here is a +1, which tells me that the right side of this graph is going to go up. So I'm going to have something that looks like that. I have both ends going up with some squiggles in the middle. So here I'm again going to create a table of values, and again I'm just going to utilize -2 to 2. Now as you substitute, I suggest being really careful. Remember, utilizing parentheses and things like that, double checking your leading coefficients, and being careful with those negatives. So if I use my calculator and I start substituting in the values, when I substitute in -2, I find a value of y to be 12. Then if I repeat that with 1, I find a y value of 2. If I repeat that with 0, I find a y value of 4. If I repeat that with 1, I find a y value of 0. And if I repeat that with 2, I find a y value of -4. So here, if I go ahead and plot those, -212 is kind of off the graph here. -1, 2 comes down to about here. 0, 4 means it comes back up. 1, 0 means it comes back down. 2, -4 means it comes back here. So while I'm not going to have a perfect graph here, I do have an idea that both ends are shooting upwards. And so I can kind of get a little bit of the squiggle and then make sure that both of my end behaviors are pointing up due to the even function and the positive leading coefficient.